Hello friends, good morning. So here we are today to demonstrate the experiment of to find the volume of metal ball by using measuring cylinder using displacement method and verify it. We will verify it by using vernier calipers, or theoretically we will calculate the volume of bob, and we will calculate the volume of bob by practical methods, by displacement method, and we will check that both the volumes are coming out to be right or not. So apparatus we are using is, we have metal bob, we have measuring cylinder, we have water in the measuring cylinder, and vernier calipers through which we will find out the radius of the bob, and this is metal bob tied with the thread. This is we have. And the theory part, the theory that we are going to use here is Archimedes Principle. By the mean of displacement method, we mean about the Archimedes Principle, which states that whatever volume of the body is submerged in any liquid, the liquid will get displaced, and the amount of liquid, the volume of liquid displaced, is always equals to the submerged part of that body. If it is fully submerged, then the volume of the displaced water will be exactly equals to the volume of that submerged body. So we will be using this part as an experimental, and this theoretically, the second part that we will verify by using vernier calipers. So in that we will use volume of the bob by using a mathematical formula, which is 4 by 3 pi r cube. The bob is supposed to be a spherical.
So as we can see that in our measuring cylinder we are having grids, and we can find out the least count of this grid by using the formula, that is final reading minus initial reading and number of upon divided by the number of divisions it has. So we can see that it is 20 and it is 10, and the number of divisions are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we can do, we can 20 minus 10 by 10, which is 1 ml. So this small division, it is 1 ml. This is small one. This division, this is measuring only if the liquid is at this level, so it is 1 ml. If it is at this level, then it is 2 ml. If it is on this level, then it is 5 ml. Similarly here, if it is, then it is 20 ml.
So this is our experimental setup, which consists of a stand, metal stand, and this is a metal bob tied with a thread and measuring cylinder, in which if you see we have filled water up to level of 150 ml. 150 ml it is. If you see here, this is 150 ml mark here, and the liquid is filled up to 150 ml. So we will consider that the initial volume of the liquid is 150 ml. Now when we displace, when we submerge this part, submerge the bob, remember that the bob should be submerged only up to its full dimensions. Do not submerge the hook or the thread, otherwise the volume might differ. So if you see here, the water level has raised from 150 to 1, 2, 3, 4, 4 grids. It has raised from 150 to 1, 2, 3, 4 grids. Earlier it was on 150, now it is on 4 grids plus 150. Yeah, 150 plus 4 grids. Now we know that from the least count, 1 grid is of 2 ml, so 4 grids would be of 8 ml. So the final reading of the liquid now is 158 ml. So as we have calculated the volume of the bob by using measuring cylinder, and it was coming out to be 8 ml. Now we will calculate the volume of the bob by using mathematical formula 4 by 3 pi r cube, for which we will require to calculate the radius of the bob, and we will use a vernier caliper.
So here we are. So to calculate the radius of the bob, we are using a digital vernier caliper. You may use an analog also. So we will be taking the reading, and it is 24.4 mm. Now this is the diameter of this bob, which is 24.4 mm, and to calculate the radius we will divide it by 2, which is 12.2 mm. So now let's move on to the calculation part, and we see that initial level of water in measuring cylinder was 150 ml, and after displaced water reached up to 158 ml, which is final level of water in measuring cylinder was 158 ml. So volume of water displaced is equals to final minus initial, which is 158 minus 150, and we get 8 ml. We are converting it to the centimeter cube because of the our radius would be in centimeter and a volume would be in centimeter cube. So it would be much more convenient to use in 8 centimeter cube. And we know that 1 ml is equals to 1 centimeter cube. So according to Archimedes principle, we can say that volume of water displaced is equals to volume of submerged part of the body, which is whole body. We have submerged whole of the bob, so volume of the bob coming out to be 8 centimeter cube, which is equals to 8 ml. Now if we calculate the volume of the bob by using theoretical formula, which is 4 by 3 pi r cube, so we have measured with the vernier caliper, the diameter was coming out to be 24.4 mm, which is 2.44 centimeter, and the radius coming out to be 24.4 by 2, which is 12.2 mm and 1.2 centimeter. We will be taking up to 2 decimal place or 3 significant figures. Volume of the bob, so it coming out to be, by using the calculation, we get it 7.60 centimeter, which is a bit deviated from its practical volume, which was coming out to be 8 centimeter. Okay, so there is an error, and we will write that, we will calculate that. So if you see here the result of the experiment coming out to be, volume of the bob by displacement method, it is 8 centimeter cube, and volume of the bob by theoretical formula is 7.60 centimeter cube. So percentage error we can find out in the experiment, and that is due to the experimental experiment. There might be some gross error, there might be some instrumental error, and there might be some reading error. So there we have calculated how much error we have done in our experiment, and that we can calculate by using formula correct reading minus observed reading, correct reading minus observed reading upon correct reading into 100, which gives us percentage. So it is 7.60 minus 8 upon 7.60, and we get the formula. We get the error to be minus 5.23%. Thank you.